Hey guys, this one's pre-recorded because I'm probably out on vacation to see my family by the time you're watching this, so I will announce new patrons next week. As always, a special thank you to Halo Burner and Ryan Bellin for their immense support to the channel this month on Patreon. It is sincerely appreciated, gentlemen, and I hope you enjoy the video. Hello everybody, today we're going to cover elevators, which was a request from some patrons. So, I have this tile here, and you can use any object you want. I probably showed a clip of the elevator Nephilim beforehand if I edited this correctly, but just for simplicity's sake, I'm just going to use a tile. You can use a square, like just a regular mesh, it doesn't matter, it's going to work either way. I want to keep it simple because I know most people watching this video probably don't actually have a readily assembled elevator for this. If you do, awesome, go ahead and use it. So I'm going to add a script called elevator interactable to the tile/platform itself. So this script is on top of the object that I'm actually going to move. That's important because we're going to put logic here that moves it by its transform. If you want to animate any parts such as chains or ropes or whatever, just add animated references to this component or to those components up here, just like other things you want to kind of move when the elevator is moving. I use ropes in Nephilim and some chains I have to make it, really sell the idea that it's an elevator. But if you're just prototyping something for now to get the logic down, don't worry about it. The first thing we're going to need is a network position. So let's go ahead and create a public network variable, and we will call this, or rather make it a type vector3 and name it network position. I'm going to initialize it as new network variable vector3, and we're going to say vector3.0. And then we have the network variable read permissions, which is everybody. And then we need to put in the network variable write permissions, which is the owner. Now we're going to make a couple more variables regarding movement. So let's just go ahead and make another network variable. And we can make this of type bool. And it's going to be elevator is rising. Now, I'm going to go ahead and make another one for descending. I know, the common thing to do is just if it's not rising, it's got to be descending. That's totally cool. You can do that. Don't know why. Sometimes I just like having two. So I'm going to make one for rising and one for descending and just reference both as needed. But you can just do if is not rising, then it has to be descending. But if you want to have any special logic for movement, you will need to keep track of that too. So you would need to make a flag for is the elevator moving at all. So serializable field float network position smooth time. This is just going to be basically the time it's going to smooth between its position to the network position. Fair enough. And then down under here, we're going to make a header for destination. And now, since this is an elevator and mine's only going to go up or down, I'm only going to have two destinations naturally. The ground level, which you can call it, and the top level. If you want to have multiple stops, you could do that too. It wouldn't be very hard to modify what I'm going to do to set up a chain, but we're going to have two. It will be binary. So we have destination high or destination low. So you could just keep an array of destinations if you wanted to and iterate through them depending on where you're at, or use a lever to go up or down. You can get really creative with this, but I'm going to keep it simple for this video, where the elevator stops if it's rising and where the elevator stops if it's descending. Most people want to see this because I'm assuming they have trouble actually syncing the network movement and stopping the jitter of a player, which is totally fair. So I'm going to go over that as well. But for the actual elevator logic, we're going to keep it very simple, binary, top and bottom, and interact with it. And maybe I can do another video where I cover different versions of it, like controlling with buttons and levers and such. But let's go and create a protected list of character managers. Going to need to say using system.collections.generic for this. And we need to keep track of a list of characters that are on the elevator. Why is this? Because we're actually going to modify their Y position locally, so you're not fighting with the network. And if you have a bit of ping, the character is not vibrating up and down. So basically, we're going to map out the character's Y position ourselves here locally, but we're going to take their X and Z position from the network. Also, we're not going to do this video, but in the future, you want to keep track of dead characters on the elevator. And this is because if you have any kind of IK, they're going to kind of vibrate and jitter up and down, and we need to do some whimsical magic with that if they're dead. But right now, I'm going to remove this because that goes under the category of extreme polish, and it's not necessary because I'm sure most of you watching probably don't even have full body IK. Anyway, I digress. Let's make a header for sound effects. Let's make a private audio source, and let's make this elevator audio source, like so. And then let's make a serializable field here, and we need to make some clips. So the first audio clip is going to be the sound of the elevator moving, and generally speaking, this is a loop. So if your elevator is going up or down, you have the constant noise happening. And then we need to make a clip, or an array of clips if you prefer, for the sound it makes when the elevator stops or comes to a halt. So you could make the moving sound an array too and pick one randomly, but generally speaking, if you're going to use a loop, it's probably going to be the same one. So override, we're going to override on trigger enter, and we're going to override on trigger exit, and we're also going to override our on network spawn and on network despawn. So we'll start off with on trigger enter. We're going to check here and say if the elevator is rising dot value, or if the elevator is descending dot value. So there's movement of any kind really, return. We don't want to give the character an opportunity to get an interaction prompt if the elevator is already moving. Like you shouldn't be able to interact with the elevator until it stops. So on network spawn, we're going to do an override for that and on despawn. And we can write some logic here in on network spawn. So I'm going to say if you're not the owner and this just spawns in the world, well, obviously we want to see where it's at in the world and we want to make our transform that. But remember, since this is a child object of a parented object, say transform.local position is equal to network position.value. And then we can say network position.value is equal to transform.local position if you're not, or if you are the owner. So if this is not a parent, obviously you can use transform.position, but because I have this parented, I'm using local position, that's important. If you want to set up your hierarchy different, just plan accordingly with that. If the elevator is rising, then we want to activate the elevator and pass true. Now this doesn't exist yet. True meaning is rising. If the elevator is descending, we want to activate the elevator and pass false. False for it is not rising, so it is descending. So this function does not exist yet. But basically, if you join the game and the elevator is already moving, you want to set the position where it is from the host and then start moving it. So it kind of keeps in tow with that. Okay, so now private void activate elevator. Bool is rising. So if it's true, it's rising. If it's false, it is descending because activating the elevator is always going to start it, moving it. Next, we're going to make a private enumerator, move elevator. If you want, you can call that move elevator coroutine, since I kind of always use that keyword when I make coroutines. And we're going to pass a bool for is rising. Importantly, if you're using more than two locations, you want to pass a destination here, not a bool for is rising. And likewise, on the activate elevator, you want to do the same thing. You don't just want to have it binarily up or down. You need to get its location of where it's headed to. So under move elevator coroutine, interactable collider dot enabled is equal to false. As soon as this thing starts moving, you do not want people to interact with it. We're going to say elevator audio source dot clip is equal to elevator moving sound effects, and then we call elevator audio source dot play. And I'll put you return null so it stops throwing an error, but we also need to say using systems or system.collections for us to be able to use the enumerator. So up here, using system.collections, good. And then down here, we can continue. So I'm making a comment here, make recall interactables. Whenever we do that, if someone is standing in a recall zone and someone starts the elevator, we want to remove the interaction from them so they can't recall the elevator. So for example, if we have an interactable lever that makes you recall the elevator at the top and your friend is standing in it when you start the elevator from the bottom, you don't want your friend to be able to activate that lever. So temporarily remove that interaction from them while the elevator is moving. Now we're going to say while transform.local position does not equal destination, and we don't have destination yet, so let's make a local variable here. Vector3 destination is equal to, and we're going to start by saying it's equal to destination high. Now, if we're not rising, we're going to override it immediately to destination low because it's binary. It's either top or bottom. Very simple. Like I said, if you're using multiple stops, you can make it a little bit different. So while the transform.local position does not equal our destination, we're going to say transform.local position is equal to vector3 move towards transform.local position destination move speed times time.delta time. Importantly, this assumes your elevator is going up or down and not moving left or right. If you're moving left or right, you'll have to do a few different things if you wanted to move along a specific path. But this is just going to assume it's going straight up or straight down. Okay, vector3 velocity of movement is equal to vector3 move towards transform.position, the same thing, destination move speed times time.delta time. Why are we keeping the velocity of movement? Well, we need to modify our character's y position based on that. So let's see. If we are the owner, network position.value is equal to transform.local position. Now, I don't like this new autocomplete on the new Visual Studio. There we go, for loop. So now we iterate through every character on the elevator, and here's where we modify their position so it doesn't give you that weird network jitter. Because again, if I'm playing in Canada and you're in Poland and we got in the elevator, you're going to be a moment of getting my position, and it's going to say that my Y position is different than where your elevator's at, and that's going to look like me jittering through the floor. So this is going to remedy that. First of all, if the character is null, continue, And then we're going to say if the character is not jumping, we're going to do some wizardry here. Now, if they're jumping, leave them alone. Let them apply their own Y position because that should look pretty normal. At least it does on my end, and I've tested with people all over the world. So we're going to say characters on elevator I.transform.position is equal to new vector 3. And we pass transform.position x. But now for the y, we're going to simply pass our velocity of movement dot y. And we pass the transform position dot z of the character. Now, there's a small problem here. This is going to assume the transform dot position of this elevator. But if you have, let's say, a piece of board, and the board comes up a little bit off of the 0 position of the y on this object, it's going to look like your character is sinking into the floor because it's going to go right to the 0 point of the object. Like the 0 point of our character is their feet. The 0 point of a piece of board will be right under it. So for that reason, let's add a float movement offset. I'm just going to guess. It's probably a lot lower than this, but I'm going to say 0.3f. And we're going to apply this y movement offset to the character's y. And what this is going to do is, this is going to be the exact height of the thing you're standing on. Okay, so let's take that y movement offset we've created, put it right here. All right, so now we have our y movement offset in place. And now we're going to make a comment down here. If you use foot IK, temporarily disable it, at least in my experience. Basically any form of foot IK I had on here was kind of not playing too nicely with this. Might not be the case for yours, but if you find your feet are having weird artifacts or doing weird things, just disable it temporarily while you are on the elevator. Okay. Now I'm going to say if characters on elevator I.gameObject is not active in the hierarchy, let's remove it from the elevator. We don't have this function created yet, but let's create it. Let's call it remove character from list of characters on elevator. So I'm actually going to put this up top as well before we apply any new movement. And I will put that right there, like so. And I'm going to put this warning for the foot IK as well before we apply any movement. All right, looks good. So why are we doing this? Well, sometimes when you defeat an enemy, we're going to disable their game object with some enemy types, at least I do, Nephilim. And when my character has been killed, after a few seconds, they're also disabled. So we want to go ahead and make sure we're not applying any transforms after that. So we're going to say down here, if we are the owner, elevator is rising and elevator is descending is going to be set to false because this is going to be at the point which the elevator has reached its destination. And you might want to put elevator.transform.position is equal to the destination exactly. Otherwise, it might not arrive perfectly at it, but I haven't had any issues with that yet. If it does, I will go back and add it in because we're going to test it in the series anyway to make sure it's all working. All right, so to do, make the recall interactables turn back on. So if your friend's waiting at that lever, like I said earlier, and he's still standing in that zone, he's going to get the prompt to say, pull lever to make the elevator come to him if the elevator's not there. Now, I'm going to make some comments here. Sound effects, move the elevator, and then we're going to say set the destination, or decide the destination is probably a better way to phrase that. And then down here, we're going to make a comment, stop the movement flags. And now we can play some sound effects as well. And we're going to say stop the movement sound effects. And then we can play the stopping sound effects. So first stop the loop by saying elevator.audiosource.stop. And then we can actually play the stopping sound effects. Now you could write some code here to select random sound effects based on the array, but we've already got a nice function set up for that. So we're going to say elevator audio source stop play one shot, and we're going to say world sound effect manager instance choose random sound effect from an array, and we pass our array. Okay, very good. Now I'm going to make a comment here too. Play the stop or stopped sound effect. Then I'm going to say if you are animating any part of the elevator, such as ropes, chains, etc., if you have anything going on in the background, this would be a good place to stop that as well. Okay. Now I'm going to right below that, I'm going to say interactable collider is equal to true. It's come back on because the elevator has stopped moving. So I'll make a comment here too, re-enable the interactable collision. And this makes it so if you come onto the elevator again, you're able to collide with it. All right, looks good. Now I'm ripping a lot of this stuff straight from my notes and slightly modifying it. So when we get around to testing, I have to modify a couple of things, but that's yet to be seen. So first off, up top here too, let's make sure that we interact through all the characters on the elevator. And if they're null, continue. Then we're going to search for players specifically on the elevator. And what we're going to do here now is if a player is on the elevator, we're going to, at the start of movement, remove this interactable from the player. So if there's a pop-up, for example, that says start the elevator or ride the elevator, it's going to remove it the second the elevator actually starts moving. And now likewise, if your elevator and interactable space are on the same space, so what I mean is if the interactable square is the same trigger or on the same object as your elevator, then you can also re-add it after the elevator stops. Because if you're on the elevator, then you're going to be within the trigger radius, and that would make you see the trigger pop up for riding the elevator. So I'm going to say private void add character to list of characters on elevator, and then remove character from list of characters on elevator. Obviously we'll make as well, but all we're going to do here is make this require a character manager, and then we're going to say if characters on elevator contains character, we want to simply return, don't want to add them twice. Otherwise we're going to say characters on elevator dot add character, but we need to create another flag as well. Let's go to our character locomotion manager. We need to know if we're being moved by another object. So I'm going to say public bool is riding any form of a lift. So is riding lift is equal to false. Now, this could also be called is being moved up or down, or is being moved on y-axis, because we're going to use this to know if we should ignore using the network variable, network position y. So down here under update in character manager, if we're not the owner, you can see here we're setting our position based on the network position right above, and then a rotation, fair enough. But if we are riding a lift, we want to not set the actual full network position. We only want to set the network X and Z, so the forward and backward and left and right, not the up and down. We're going to do that by creating a vector3 new position, and we're going to equate that to the character.networkPosition.x. So we're going to say networkPosition.value.x. Then the transformPosition.y, so the local transform.y of the character. And then the character.networkManager, we're going to say networkPosition.value.z. And then we're going to apply that the exact same way we applied above by using a transform.position smooth damp. But we can actually just copy that if we wanted to. We can copy everything from here like so. And I'm just going to paste that right here. And then instead of referencing it with the network position dot value on the second variable, let me just make this a bit cleaner so you can see it. I'm going to replace that with the new position. And there we go. Now if you are riding a lift, we're not going to take the Y position from the network position. It is overridden locally because our Y position is going to be assigned by the character riding the lift. Okay, very good. Now let's save that. Go over to the elevator interactable, and now let's right below adding to the list, say characters on elevator dot character locomotion manager. Character dot character locomotion manager, not characters on elevator, is riding lift is equal to true. And now we copy all this, including the function, and we just invert everything and change add to remove, and we're going to say to from. And now, of course, we're going to change also is riding lift to false. And we're going to check if we're not on the list of players return, because we can't remove what's not there. All right, and we can save that. So on untrigger enter, before checking if the elevator is rising or descending, you can add the character to the elevator by seeing if the other collider is in fact a character. We can do this by saying add character to elevator, and then right above that we're going to say character manager, character, is equal to other.getComponent character manager. And then we're going to say if character does not equal null, add character to list of characters on the elevator. And then we're going to make this require a character so it passes the character. Now do the inverse on trigger exit by removing them. And we're going to say if the character does not equal null, remove characters from list of characters in the elevator. Now, in some instances, you might want to make the trigger of an elevator different than the actual, or rather, the space where your character is standing on an elevator different than the actual trigger space. And I'll go over why and what you'd want to do, but don't worry for now. We're going to make this simple and then expand upon it and get into nuances after we know it's all working. So we're going to go under interact and saying if the player is owner, activate elevator server RPC. This doesn't exist yet. Server RPC require ownership is equal to false. Private void. We're going to say activate elevator server RPC. Okay, there we go. Now we need to copy this and paste it because we're going to need a client RPC as well. So copy everything, paste it, change the keyword from server to client, and remove the require ownership. Activate elevator client RPC. Now we're going to say on the server RPC, if this is the server, then we're going to call activate client or elevator client RPC. Now what are we doing here? Well, it's pretty simple because it's just binary. We're going to say if transform.local position is equal to destination high, then we know we have to move towards the low. So we're going to say if is owner, elevator is descending dot value is equal to true, and then we're going to activate the elevator and pass false because we're not rising, we're moving down. Now we can do an else if, and this is where I said if the position is not exactly the same as the destination high or low, it won't move. So make sure you, if you do have issues, just set your position to that after the coroutine is processed. Then we're going to say elevator is rising is equal to true, activate elevator is equal to true. Okay, that is all the time we have in this video because I realize this is taking quite a while. So in the next video, we're going to test to see if this works, and then we're going to get into trigger zones, such as recalling the elevator from different points, potentially using different interactables, but also why you may want the area that you're allowed to interact with an elevator be smaller than the area of a person standing on an elevator. For example, let's say you want to activate an elevator with a button in the center, then the area which the characters are standing on the elevator is bigger than the area at which you can interact with the elevator because that button is in the center and a smaller trigger. So to do something like that, we would use another game object that has a script on it, and when you pass through the trigger on this script, you're added to the list of characters in an elevator. I will cover all of this because there's many different types of elevators that you may want to put in your game depending on the vibe or the feeling, so I'll go over all that as well. Okay guys, thank you very much for watching. This one was pre-recorded because at this time now when you're watching this, I'm probably out visiting my family on vacation as it is Christmas. So I hope you all had a very lovely Christmas to those who celebrated. A special thank you to my patrons. It is because of you the series can exist at all. And a shout out to the people who take the time to like, comment, and share this video via word of mouth. You have my sincerest gratitude. I'll see you guys in the new year.